A watermelon costs $4 per pound. How much would M pounds cost? Okay, so this is just simply writing a story using an equation, right? We're writing an expression. If 1 pound is $4, 2 pounds are $4 for the one plus another $4. 3 pounds are 4 plus another 4 plus another 4. What we see here is that we're saying, okay, this is just 4. This is 4 but times 2, right, to get 8. This is 4 but times 3 to get 12. We can continue this and say we did 6 pounds are 4 plus 4 plus 4 plus 4 plus, 1, 2, 3, 4, 5 plus 4. This is just 4 times 6, right? Because we're adding 4 6 times. So $24. So what we end up seeing is that all of these expressions have that 4 times the number of pounds. A store charges P dollars per notebook. What is the total cost of 5 notebooks? Okay, well, total cost is going to equal to something. If 1 notebook is P dollars, 2 books is going to be that price of 1 plus the price of 2, right? So adding the price twice. 3 books is 1 plus the second plus the third. Again, we see this pattern of P times 1, P times 2 books, and then the P dollars times 3. And again, we see the pattern, so the dollar amount, so the P dollars, times the number of notebooks, which is 5. Right? That's what we're saying, because we have 5 notebooks. Well, the total cost is going to be the price times 5 notebooks. How many solutions does the equation 2x minus 3 is equal to 2x minus 6 have? Okay, what does the idea solutions mean, right? How many solutions? Okay, well, in algebra, solutions typically refers to how many values can we plug in here that will make this statement true, meaning left-hand side equals right-hand side. In a simple example, 2 times 3 is equal to 2 plus 2 plus 2, which is 6, right? So even though they're written differently, they both equal the same thing. Okay, so how do we determine that? Well, the best way is to actually expand this out and solve for x, see what we get. Now, what happens when you would do that, you would notice 2x minus 6 is equal to 2x minus 6. We end up with exactly the same values on the left-hand side and right-hand side, which is as expected, okay? And what we see is that, well, we can infinitely put any value for x in here, and we'll always have some sort of solution. So, infinitely many.